Hello and welcome to my tutorial on esterification and the dehydration of alcohol. So, an ester is formed when an alcohol is warmed with carboxylic acid in the presence of H+ ions, and it's called esterification. So, concentrated sulfuric acid is usually used to catalyze the reaction. And esterification is the reaction of an alcohol with a carboxylic acid to produce an ester and water. So these particular functional groups are very important because the OH and the H group bonds break during the reaction, and a water molecule is broken off to complete the reaction, and this is the ester here. So this will be methyl I had a slight problem writing the word methyl today. So this is methyl propanoate. So you can make an ester by in a boiling tube and 1 milliliter of the carboxylic acid and the same amount of the alcohol. Then you add a few drops of concentrated sulfuric acid, and you put the boiling tube in the water bath at 80 degrees for 5 minutes, and then you pour the product into a beaker of cold water. You will then see the oil floating on the surface of the water. The oil is a sweet smelling ester. So I only say don't sniff too hard because the actual fumes are slightly overpowering. So looking at the textbook here, I can show you the apparatus of the making an ester. So you just have the mixture of sulfuric acid, ethanoic acid and ethanol, and then you just stick it in the water, and the water heats up your mixture, and then the ester is formed. No evaporation should occur, as the boiling point of water is 100 degrees Celsius, and the only thing that should be evaporating off is water when it becomes steam. So also esters are present in bananas and oranges. This is octyl ethanoate, so you have 1, 2, 3, 4, 5, 6, 7, 8 carbon atoms, so that's where you get the octyl from, and the ethanoate group is this particular functional group here, and pentyl has 5 carbon groups of the functional group here. And went through that preparation of an ester. Dehydration of an alcohol. So an alcohol can be dehydrated to form an alkene in the presence of an acid catalyst. It's also called an elimination reaction. So concentrated phosphoric acid H3PO4 or concentrated sulfuric acid H2SO4 are the acid catalysts. The alcohol was heated under reflux. That's the continual boiling and reacting of a aldehyde until it becomes a carboxylic acid. Go away keyboard. The equation for the dehydration of alcohol is shown below, so we'll just have a look at this equation. So ethanol plus the concentrated H2SO4 creates the ethene, which is the simplest alkene you can get, and H2O. So quite simply, dehydration is the elimination reaction in which water is removed from a saturated molecule to make an unsaturated molecule, or an alkene. So an alkene is unsaturated as it contains, that's not all the carbon to hydrogen bonds are filled. So if we take a slightly wonky view of ethene, Then there's a carbon-carbon double bond in the middle, and these 4 hydrogens are around it, but alternatively an alkane could form, but the carbon-carbon double bond is present, so the hydrogen atoms cannot bond because the electrons are being used by the double bond. So if we now have a look at a more complex example of dehydration, down here at the bottom, cyclohexanol and this is the important part reacting. So we then form a unsaturated molecule, cyclohexene. We'll learn more about this molecule in A2, but for now you have to know that a water molecule has been removed, which is where these atoms have made the water molecule here under the phosphoric acid catalyst and a wee bit of heat. And now we'll move on to some questions, and to remind you again, there is the dehydration definition, as it is very important that you get the wording of this. I haven't seen it asked in exam papers, however, so it's nice to know that this definition isn't asked quite a lot, but it could be asked in the future, so it's probably best that you learn this one, as I always get the wording of it wrong. So the question now, write the equation of the reaction between ethanol and pentanoic acid. What is the product that is formed? Draw the displayed formula for the product of the reaction between butan-2-ol and ethanoic acid. Butan-2-ol can be dehydrated using concentrated phosphoric acid to produce 3 possible alkenes that are isomers. So they're chemically the same but a different chemical structure. Draw the displayed formulae and name the alkenes formed. So give you 5 seconds to pause and we'll continue. So for question 1, we have ethyl pentanoate as the organic product. This is ethanoic pentanoic acid. I will write pentanoic acid here. And this is ethanol, our good old friend ethanol. Then this makes the product ethyl pentanoate, where the ethanol has created a carboxylic acid group here with CH2 and CH3 group adjacent to the OH here. So if we move on to question 2 answers now, butan-2-ol and ethanoic acid, which is this molecule here, ethanoic acid, F being 2 carbons, and this is butan-2-ol, two, 1, 2, and the OH is on butan-2-ol, and this product is formed. So the product formed is ethyl ethanoate. And the answer to part 3 is but-1-ene, E-but-2-ene, and 2-but-2-ene. Thank you for watching this tutorial, and goodbye. If you want me to do any of the organic practicals and film them, like this how to make an ester practical, if my college ever does the making an ester practical or any other organic practical you would like to see, please leave a comment below. I would quite like to hear some of your suggestions. I may film some of the practical procedures just to see, or rather show you, what they all look like. because chemistry is fun, and I have new equipment to do such things. I shall see you in the next video.